Okay. Okay, so here's a general approach you gotta use here. Okay, if I told you the derivative, and now I'm asking you to think back to what the original function was, you guys would probably come up with a bunch of different answers. Okay, someone might say, well, I think f of x was this, because when you take the derivative of that, what do you get? 3x squared. Someone else might have said, okay, well, what about x cubed plus 5? What's the derivative of x cubed plus 5? 3x squared, right? So you see how there's a number of possible answers and so on? Do you understand? Okay, so in general then, instead of, we can't list every one of those, so what we do is we just say the antiderivative of that, the antiderivative of that is just x cubed and then plus some number c, right? Got it? And so c is any real number constant. Does that make sense? So c stands for constant, so c is any real number. Does that make sense? Again, it could be positive or negative. And again, what we just found is called an antiderivative for obvious reasons, right? It's the opposite of taking the derivative, right? Okay. All right, and by the way, get used to this symbol, okay? You're going to see that symbol the rest of the year. That elongated S symbol is used to indicate taking the antiderivative. And again, you guys, I'm going to start using the following words interchangeably. When I take the antiderivative, or when I perform antidifferentiation, or when I perform integrating on a function, or integration on a function, these all mean the same thing. Is that clear? Okay, so I'm going to use those interchangeably throughout the rest of the year. Okay, so with that elongated S symbol, this is the way we're going to write it. We can say the antiderivative of 3x squared is what? X cubed plus c, right? And by the way, see that dx? You have to have that, okay? That's part of the integral. And again, you can kind of look at that as just saying we are integrating with respect to what? X, okay? So make sure you put a dx. So the 3x squared is what you're integrating, but you got to have the integration symbol and you got to have dx. Always, okay? They'll actually take off points on the AP exam if you write an integral without that, okay? All right, and again, I'll kind of show you where that comes from later on in a future lesson, but just get used to putting that, okay? All right, so the question is so we don't always have to, you know, on a case-by-case basis, think backwards. We need to come up with a rule that, you know, how we had a power rule for derivatives? Well, we needed something like that for integrals. So if you think about what you did when you differentiated, you can come up with a power rule for integrations or for antiderivatives by doing the following, okay? Instead of bringing down the exponent and multiplying it out front, what would be and then subtracting one from the exponent, what would be the opposite of all that? Yeah, you would add one to the exponent, right? And then divide by the what? New exponent, and that'll do it, okay? So that's how you integrate something in the form x to a power n, okay? So to get the antiderivative, you simply add one to the exponent and then divide by your new exponent. And again, anytime you integrate, don't forget your what? Plus c. That's absolutely important. You put the plus c every time you integrate. Is that clear? Okay, Anthony, is this okay so far? Okay. All right, now I hope, you know, this doesn't confuse you because this is just, you know, this is just what the textbooks do to indicate, you know, that you're coming up with a new function after you integrate. So you'll often see on the AP exam and in your textbooks that when you integrate what we call some little function or some little f function, you get some new function which we call big F. Okay, and again, remember the big F will always have what? Plus c on it, okay? Okay, so again, taking the derivative and integrating our what? Inverse operations. Just like you learned back in elementary school that subtracting is the opposite operation of addition, right? Or dividing is the opposite operation of multiplication. It's the same thing, right? It's just the opposite operation, right? Okay. Or squaring something's the opposite of taking the what? Square root, okay? It's just an inverse mathematical operation that you're performing. Okay, so, all right, now, okay, so then if that's true, then what would happen when I integrate f prime. What happens to the antiderivative and the derivative? They what? They cancel each other out, and you're left with what? Little f, right? Got it? And then, again, because the way it's written, you'd be integrating last, you have to have a plus c. Does that make sense? Okay, so here, technically, you're taking the derivative first, and then you're integrating last, right? Because you always work from your inside out. Okay, and so in this case, yeah, even though they cancel out, you still need a plus c. Does that make sense? Okay, so what would happen if you integrate f double prime? What would that knock you down to? That would knock you down to what? F prime. Doesn't it take away one of the derivatives when you integrate? And then again, after you integrate, don't forget your plus c. Okay? All right, now, all right, let's go back to this. Okay, let's go back to this for just a second. Okay, so now I'm switching gears on you. Let's go back to that. Okay, so what would happen if I differentiate both sides of this equation? Well, I can do that. I can differentiate the left side as long as I differentiate the right side, right? You can do anything you want to an equation on one side as long as you do the same to the other side. So what happens when you integrate what happens when you differentiate this integral? What happens? What happens? It cancels out the what? Integral, and you're left with what? Little f. What happens when you differentiate big F? You get what? Big F prime. With me, Christine? Yeah? Does that make sense? Okay. All right, so again, get used to this because they're going to make little puzzles out of this stuff on the AP exam. Okay? They're going to throw a bunch of symbols up there, and you're going to have to manipulate the symbols, maybe differentiate, maybe integrate, maybe put two things together by substitution, and just kind of work your way through a little calculus puzzle. They like to do that on the AP exam, which is why I'm trying to, throw a bunch of these different scenarios at you. Okay? Do you understand each individual situation I just went over here in this box? Do you? Okay. All right, Sam, stay with me. Okay. Now, by the way, I want to make sure you understand this. You're not going to see that symbol. They actually don't use that symbol to chapter 5. But I figured while we're on the topic, I might as well introduce it now. But you're not going to see that on your homework. It's just going to say find the antiderivative. But it's the same thing. Is that clear? Okay? All right, so here's how I want you to do it for tonight. They're going to give you a function like this, and I want you to find the antiderivative. So again, what you're going to do is you're going to do the power rule. If I take this thing right here, and I add 1 to the exponent, divide by your new exponent, isn't that how I'm going to get the antiderivative? Same thing here. Add 1 to the exponent, divide by your new exponent. Same thing here. Add 1 to the exponent, divide by your new exponent. Now, technically, this is 10x to the what right now? It's 10x to the 0. So if you add 1 to the exponent, divide by your new exponent, you get that, which is just what? 10x. So instead of going through all that, what's the shortcut? What's the antiderivative of 10? 10x. What's the antiderivative of negative 6? Negative 6x, right? Assuming you're integrating with respect to x, yes? Does that make sense? Okay? And then don't forget your what? Plus c when you integrate. Okay. All right, so I'm going to call on somebody. How about Sam? Can you integrate this one for us? Okay, so x cubed over 3, in other words? Okay, then what? So minus 3x squared over 2, and then minus 5x, and then plus c. Good. Everybody agree? And again, if there's anything there to simplify, you can go ahead and do that. Yeah, you could write that as 1/3 x cubed if you want. Okay, that's fine. Okay? All right. Christine, how about this one? Now wait, you see how I'm changing things up on you? First time I gave you a function, I just said find the what? Antiderivative. The second time I put one of those symbols and that there. That also means to take the antiderivative. The third time, I'm asking you to find f, giving you f prime. And to do that, you have to what? To go from f prime back to f, you have to what? Integrate. So these are all asking the same thing, just in different ways. Does that make sense? Yes? Okay, go ahead, Christine. So what do I get then? What would little f be? Okay, good. Then what? Okay. Plus c. Yeah, you just you can just say the antiderivative of 6 is 6x. You don't need to put the 1, right? And again, obviously you can simplify those, right, and so on. Okay? Okay, now this one has some tricky steps, so I typed it up for you. Okay, and so again, it says find the antiderivative of this. So again, what I did here is I integrated or found the antiderivative of that by using the power rule, by adding 1 to the exponent, dividing by your new exponent. And please, you guys, take a look at what I did here. I rewrote that as 6x to the half so I can use the power rule. Everybody agree I need to do that before I can use the power rule? And then I added 1 to the exponent, which gives me 3 halves, and I divide by my new exponent, which is 3 halves, right? And by the way, I can invert that and make it a 2/3, and then what's 2/3 times 6? 4. And then clearly I turn that into the square root of x cubed, which by the way, you should all be able to simplify by now into x square root of x. So after I change x to the 3 halves, the square root of x cubed, I change it to x square root of x. Okay, so again, you guys, I think if you look at the answers in the back of the book, I might leave it as x to the 3 halves. Yes. Yes, thank you. See? It's easy to forget. Thank you. Forgot C. Good catch. Okay. All right, so again, you guys, I want to emphasize the fact that the back of the book answers might leave it as x to the 3 halves. I don't want you to stop there. I want you to keep going. Is that clear? Because again, if I check this assignment, I'm going to be, checking that you guys simplified your radicals all the way to the end. Even though the book might not when you check the answers. I want you to keep going. Because you know how it's going to be on the test, right? You're not going to be able to pick out the right answer unless you're able to simplify these radicals. Is that clear? Okay. Ryan? Water. Okay, put it away for me. Thank you. Okay. All right, now look. I'll tell you right now, there's no product or quotient rule for integrals. So you're not going to be able to integrate that the way it is, are you? If there's no rule for integrating a quotient. Okay, so what you're going to have to do is a bunch of algebra 1 before you're able to turn that into something you can integrate. So here's what I'm going to do. Any suggestions? Yeah, in other words, well, what you're suggesting is another way of breaking it up, right? Can I break this up? Somebody tell me how to break this up using some algebra 1. Without pulling it out and making x to the negative third. I mean, that's going to accomplish the same thing, but what's a simpler way to do it? Go ahead. Yeah, how? So what would it turn into? Okay. Okay. All right, I can do that, right? Isn't that a legal algebraic maneuver right there? Yes? And by the way, algebra 1 allows you to combine those into x to the 4th, doesn't it? And then you can think of this as x to the 1/2. And so again, when I combine those, don't I subtract the exponents from top to bottom? Isn't that the algebra 1 rule? You take the 1/2 minus the 3, which gives you x to the what? Well, 6. Isn't this the same as 6 halves? So a half minus 6 halves is what? Negative 5 halves. All right, so I haven't done any calculus yet. That's just algebra 1, isn't it? Isn't it? And so now, have I turned it into something where I can integrate very easily using the power rule for integrals? Everybody agree I can do that now? Okay, so Ryan, you can help me here. What's the antiderivative of that? The antiderivative. What's the power rule? You what? Okay, there you go. Yeah, you add 1 to the exponent and then divide by your new exponent, right? Isn't that the power rule for integrals or antiderivatives? Okay. Alex, go ahead and try this one. Add 1 to the exponent, divide by your new exponent. What do you get? Okay. Over negative 3 halves. And then again, don't forget your plus c, guys. Does that make sense? Okay? All right, from here I'm just going to clean it up. I can make this 1/5 x to the 5th. I'm going to invert that and multiply, giving me a plus 2/3. And by the way, I'm going to move that to the denominator to make it a positive exponent. Okay, guys, with me? And then I'm going to change that to a square root. So I can do that off to the side. Okay, I'm going to do that off to the side. That's the square root of x cubed, which is the same as square root of x squared times x to the first, which is just what? Which is just what, guys? X squared of x. Everybody agree? That's just x squared of x. And again, maybe eventually we'll be getting common denominators on this, but for today, this is more than good enough right here. Okay, guys? Any questions? We good? Okay. All right, so again, at this point, I've got to keep stressing that taking the derivative is just, or taking the antiderivative is just the opposite of taking the derivative, right? So, you see all these? You guys already know all these. You already have these memorized, right? So, for example, you all know that the derivative of sine is cosine, right? You all know that the derivative of cosine is negative sine, and so on. You all know that the derivative of ln of x, or ln absolute value of x, is just 1 over x, isn't it? Okay? You all know the derivative e to the x is e to the x. Now, you might not remember these right away, but I mean, at this point, guys, I really do want you to start memorizing those two things, okay? I think I gave them to you the first time I tested you on those, but from this point forward, I really need you guys to memorize those, because if you don't memorize those, then you're not going to be able to take the antiderivatives. Is that clear? Okay, so again, these are formulas I gave you before. The derivative of the arc sine or inverse sine is 1 over the square root of 1 minus your x squared. And here's the tangent one. So please memorize those. I think you already know these. I made you memorize those in the past. But these I gave you, but now I'm going to ask you to memorize those. Okay? So now at this point, remember, these are derivatives. You already know these. So now we're going to go backwards. In other words, if the derivative of sine is cosine, what would be the antiderivative of cosine? Just sine. And then don't forget your plus c when you integrate. Is that clear? Okay? If you already know that the derivative of cosine is negative sine, what's the antiderivative of sine? Negative cosine. Is that clear? Going backwards, you got to have that negative in there, right? Okay. Since the derivative of tangent is secant squared, going backwards, what's the antiderivative of secant squared? Tangent, and so on. Now notice something. You all know how to integrate secant squared because it's just the opposite of a derivative rule you already have memorized. But have I shown you yet how to integrate just plain old secant? Have I shown you that yet? No, that's for another day. So just understand what you can and cannot do right now. The only things you can do right now, you know, as far as this list goes, are things that you already know the derivatives of. Does that make sense? Okay, so again, let me keep going a little bit. Since you know the derivative of secant is secant tangent, what's the antiderivative of secant tangent? Secant, and then plus c. Okay, since you know that the derivative of natural log of x is 1 over x, what's the antiderivative of 1 over x? Natural log of x plus c. Okay? Since you know the derivative of e to the x is e to the x, what's the antiderivative of e to the x? E to the x plus c. Since you know the derivative of that is that, what's the antiderivative of that? That plus c. Okay, now, now I want to pay special close attention to this one. Okay? Because it's very easy to overuse that one. And I see it every year. And hopefully I'm going to stop that today before it ever happens with you guys. Okay? So pay special close attention to that one. And let me show you what I'm talking about. Ready? What if I asked you to integrate these? Again, right now they're a quotient. And there is no quotient rule for integrals. So any ideas on how I'd integrate these right now? Yeah, I can make that x to the what? Negative 2. And by the way, don't forget your dx's. Okay. So then at that point, can I just use the power rule? Okay. By adding 1 to the exponent, dividing by your new exponent, and you end up with this, right? No problem? Everybody agree that works? Okay, what do I do here, Anthony? Write it as what? Yeah, write it as x to the negative 3. And then at that point, I can use the power rule, right? Okay, so what do I get, Anthony? Go ahead. X to the negative 2 over negative 2. And then, of course, again, just a little simplifying, and you end up with this, right? Okay. You see how this works? No problem? And I can keep doing this. And I don't care what the power is. The same strategy you guys just went through with me will work on any of these types of functions, right? All right, now let's see what happens on this when the power is a 1. Let's see what happens. Okay, so what might I do? What do you think, Joey? What might I do here using the same approach? Write it as what? Okay, wait. Before you take the antiderivative, just using algebra 1, isn't that the same thing as that? Right? I just bring it up and make it make the power a negative 1. Okay, so I haven't done any calculus yet. All right, now you can do the calculus. What do I get when I use the power rule? Uh-huh. See how we use the power rule? We ran into a problem, didn't we? You can't divide by 0, so this doesn't work, does it? Right? Doesn't work, but that's okay. Why is it okay? Because you have the fact that since the derivative of natural log of x is 1 over x, we can just go backwards and say the antiderivative of that is natural log of x. So you see how the power rule fails in this situation? So this is the only time you would use natural log of x. So the mistake that students make is that they use that on something like this, or this, or this, or this. Obviously, it doesn't apply, does it? The natural log rule doesn't apply there. You can just use the power rule by using little algebra 1 first. So on something like 1 over x to the first, that's when you use the natural log property. Okay? You see the difference? You see why it works on all of these, but this is the one time where it fails, but that's okay, because we can use the natural log. Okay. So I just wanted to spend a little extra time on that one. But the rest of them are pretty straightforward. They're just the derivative rules you already know in reverse. Okay? Okay. And again, I kind of warned you about this earlier, and here it is again. We all know that the derivative of tangent is secant squared. So going backwards, the antiderivative of secant squared is tangent. But you do not yet know how to integrate plain old secant. So just, again, just be aware of what you can and cannot do as of today. Okay? We'll get to that on another day, but as of today, we can only integrate it if it's secant squared. Okay, so, all right, so it says find the antiderivative, and so I'm just going to call it big F. That's just what we do. Okay, when we integrate little f, we typically call it big F. Okay? All right, so Allie, what do you think here? What's the, so you already know the derivative of that, so going backwards, what's the antiderivative of e to the x? E to the x. And you guys don't let that constant bother you. You're basically pulling it out and just leaving it there and worrying about the rest of it. So go ahead, Allie. What's the antiderivative of cosine? Okay. Yeah, since the derivative of sine is cosine, you went backwards. You said the antiderivative of cosine is sine, right? Okay, good. Okay, any questions on that? It's just using your derivative rules backwards. Okay? Okay, James. How about this one? Again, I want to find the antiderivative, which we just typically call big F. Okay, no big deal, but go ahead. So what would I do here to find the antiderivative of that? Okay, just use the power rule. That's good. Okay, I think you did 2 steps at once. So let me do 1 step at a time. So I'll leave the 3 there, and then what is the antiderivative of sine? Negative cosine. Okay? Again, you guys think about that. Since the derivative of cosine is negative sine, going backwards, the antiderivative of sine is negative cosine. That's good. And then, what about this one? What do you get when you integrate secant squared? Tangent x. Good. And again, yep, plus c. Very good. See what he did, guys? He knows that the derivative of tangent is secant squared. So going backwards, the antiderivative of secant squared is just tangent. And then, yes, you're right. If you should definitely change that to a plus 3 cosine. I mean, I don't have the space there, but you can definitely change that to a plus 3 times cosine of x. Okay? All right. All right, let's look at example 8. Again, I'm just trying to give you a variety of the different types of functions you're going to run into. Okay, so here we go. All right, so Pooja. We'll do these one at a time. What's the antiderivative? ln of x? Yeah, you guys just don't forget to put your absolute value on the x. Okay, it is ln of x, but we do need the absolute value. That is part of the rule. Okay? All right, go ahead. Plus secant x, good. Minus 2x. And don't forget your what? Plus c, good. Okay, any questions, guys? Okay. All right. Now, example 9 is going to take, a little bit of algebra 1, so we'll go through this one a little bit slower. Okay. And again, you guys, there is no quotient rule for integrals. So what I'm going to do is I'm going to rewrite those using algebra 1 like I showed you earlier in the hour. By the way, I'm going to rewrite it actually like that. Okay. And notice how I kind of left this one as 1 over x, but I changed this one to x to the negative 2. Anyone want to tell me why I did that? Why did I not change this to x to the negative 1? Go ahead, yes. You're right. You can't use the power rule on that, but if you change, you're right. If you change it to x to the negative first, you couldn't use the power rule. Everybody catch that? Okay, but this one, as I just showed you a few minutes ago, you can use the power rule on. Okay? All right, so just be careful on how you're setting this up. It'll make it easier on the next step. Okay, so again, then, at this point, I'm going to ask for your help. Okay, so how about Danny? What's the antiderivative of that? Okay. Now, is there a negative in the original derivative formula? So should there be a negative here? Yes, there should be. Good. Okay, so make sure you put a negative there. Okay, everybody see what he did there? Again, I'm just going to flip back a page. All he did is use this derivative rule backwards. He saw that he had to integrate cosecant squared, and so that's where he got cotangent from, right? Going backwards. Okay? And again, there was a negative in the derivative formula, so there needs to be one here. Okay. All right, how about Max? What's the antiderivative of that thing right there? Okay, good. And then how about Taylor? What's the antiderivative of this? Over what? I'm sorry? Oh, wait, did you say negative 1 or did you say negative 3? Well, again, what happens when you add 1 to that? You get what? Okay, I thought you said negative 3. Yeah, you're right. It is negative 1. Okay, then over what? Negative 1. And then don't forget your what? Plus c. Okay. That is correct. She added 1 to the exponent, giving her negative 1, and then she divided by her new exponent. Okay? All right, so at this point, just going to clean it up a little bit, and then we're good. Okay. All right, as you can see, I'm just trying to show you a pretty good variety of things you're going to run into. Yes?
Why do you have to have an absolute value on that one? Isn't it like already implied that you can't have a negative value?
Right. That's exactly why. Okay. Okay. All right, so example 10. Okay, now again, you're going to need a little bit of algebra 1 on this, and I did the algebra 1 on the last one. I'm going to have you guys help me with the algebra 1 on this one. So, Narek, what would I turn this into using algebra 1 to turn it into something I can integrate?
X to the -1/2.
Good. Everybody agree you would turn it into that to set it up for the power rule? Okay, guys? All right, so at this point, again, you guys, you see how I'm trying to change things up on you? Here I'm showing you the integral symbol. Here I'm asking you to find f, giving you f prime. Isn't this all going to require integration? I'm just trying to show you the variety of ways you're going to, you know, I'm going to communicate finding integrals or antiderivatives. Is that clear? Everybody agree to go from f prime back to f, you have to integrate? Yes? Okay. All right. So, how about RIA? So to get little f, you have to integrate. Okay, go ahead. I'm sorry, go ahead. X to the half, that's right. You added 1, that's right. Then what? Don't forget your what, though? Plus c. Okay, and then what can you turn this into? Okay, times 2 plus c. Very good. Make sense, guys? Okay? All right. So, example 11. Yeah, I'm sorry, guys. I know I'm doing a lot of just basic examples, but again, I'm not going to do this a whole lot after today. So, hopefully, after all the repetition today, this stuff will be permanently embedded, right? So that when you run into in the future, it's just automatic, right? That's what I'm trying to reach with you guys, okay? And again, I am still giving you a variety. As you can see, example 11 is not like anything we've done yet. Is it? Okay, so example 11. You've got f prime. Okay, and now again, you guys, I know you're tempted to go ahead and add one of the exponent, divide by your exponent, but you can't do that. Not when you've got a composition like this. If this was a single variable, then yeah, then go ahead and use a power rule. But this is not a single variable. Everybody agree that this is not in the form where you can use a power rule? You agree it's not? Okay? And by the way, there's no chain rule either for integrals. There's no chain rule either. Okay, so what in the world are we going to do with it then? Well, let me ask you. Using algebra 1, isn't this the same thing right here? Isn't it? Isn't that the same thing, guys? Okay. And is it okay with you if I write it like this? Is that okay with you guys? All right, now, look at your list. Look at your list here. Does that right there look familiar to you guys? It should. What is it? It's your what? It's the result for the what? For the inverse sine derivative. So going backwards, what's the antiderivative of that thing? Inverse sine, isn't it? And by the way, the constant just kind of stays there, right? Plus c. That's it. You didn't even do any work. It's just a derivative rule backwards, isn't it? No work required. Just little memorization. All right, good. See, that one turned out to be easier than you thought, right? Okay. All right, now we're going to take it a step further. Okay? All right, so what's different about this problem right here? Well, this looks a lot like some of the previous examples. But what's new is this thing right here. Okay, so I give you some additional information, and I'll tell you right now, it's no big deal. All that's going to do is at the end, it's going to allow you to find what? C at the very end. Does that make sense? So by giving you the fact that we want to use f of 4 equals 7, I want you to find one specific c instead of letting c be any real number. By providing you that additional information, I want you to figure out what the one c value would be if you know that f of 4 is 7. Does that make sense? Because when you put c, it can be anything, right? Okay. All right, so it starts out the same then. And by the way, there is, again, there's no power rule I'm sorry, there's no product rule. Okay, so when I present you with something like this, and I ask you to integrate, again, there's no product rule for integral. So what are you going to have to do first before you can do anything? What do you think, Joey? Distribute, good. Okay, so I'm just going to distribute. And by the way, using algebra 1, can I combine those into one thing? What do I get? X to the what? 3/2. Okay, so again, I haven't done any calculus yet, guys. This is all algebra 1. I'm just setting it up to integrate. Does that make sense? You see I turn these into something now where I can use the power rule? Okay? All right, so Andrew, when I integrate, isn't f prime going to turn into f? Yeah. Right? Okay, so what do I get when I integrate here?
2x squared over 2.
Okay, good.
Minus 5x to the 5 halves.
Over.
5 halves.
Okay, and then
Plus c.
plus c. Yep. Thank you. Very good. And now I'm just going to clean it up. Is that right? Make sure I didn't make any mistakes there. And by the way, off to the side, I'm going to simplify this. Remember, since the root is 2, I want to change that to as many powers of 2 as I can. Remember we did this on the summer packet? Do you remember that? Okay, so what does this turn into then? Turns into what? X squared what? Square root of x. Everybody agree? Okay. Okay, guys? All right, so just coming back now and replacing it. And again, you have to do this on your homework. I don't want you leaving it as x to the 3/2 or x to the 5/2 or whatever. Okay, I don't want you leaving it like that. You've got to keep going. Okay. All right, now, normally we'd be done, right? This is my antiderivative. However, with that additional information, now knowing that, what was it? F of 4 was what? 7? Okay, knowing this, c can no longer be any real number, because if c is any real number, you're not going to get 7 when you plug 4 into here. Do you agree? Do you agree with that? And so by plugging this information into here, you're going to figure out what c is to produce the 7. Ready? Okay, so what should I replace this with, guys? Replace that with what? 7. And at the same time, replace the x with what, guys? With 4. Everybody agree that's what you're going to do? And now you'll be able to solve this thing for c. Okay? All right, so just simplifying this. What's this? 32 times 2, is that 64? Is that right? Is that right? Is that right? Yeah, that's right. And so then this is negative 48. And then when you add 48 to both sides, you get what? 55. Okay, so what I want you to do is update or refresh this thing. And what do I get when I update that with my c? What do I get? Okay, very good. Okay, so you see I was able to find c if they give you this. And by the way, this is called an initial condition. And by the way, what we're basically doing here is we're solving an equation with a derivative in it. This is called a differential equation. A differential equation is simply an equation with a derivative in it. And to solve it, you need to find the original function. Does that make sense? And by the way, after you guys, if some of you guys go in engineering or major in math, obviously you're going to have to go beyond Calc 3, at least a couple classes for engineering. And the class after Calc 3 that you would typically take, I mean, some colleges call it Calc 4, but most colleges just call it differential equation. So basically it's an entire course on doing this type of stuff. Okay? You'd be taking an entire course after Calc 3 doing this exact type of stuff. It was a fun course. Yeah. I should find my old college textbook and bring it in. You guys would appreciate it, I think. If I started flipping through it, yeah. What's that? No, not really. Wasn't meant to be, but I don't know. Hey, if you guys don't appreciate it, who would, right? Right? Okay. So, all right. Okay, you want to do this one together? Yeah, we're going a little bit low on time, so why don't we do example 13 together? You're going to help me, though. Okay, I know this stuff is kind of grueling, which is why I'm making you guys participate so much, because otherwise I'm going to lose you. Okay. Okay, this time I give you a couple different initial conditions, right? I give you an initial condition for f, and I give you an initial condition for f prime. So we're going to use those later on. For right now, let's just start with this. Okay, it says to find what? We're trying to find what here, guys? Trying to find what? F. Well, how am I going to go from f double prime to f? By doing what? I'm starting with f double prime. How am I going to turn f double prime into f? By doing what? Integrating once, twice, 3 times. How many times is it going to take? Everybody agree? You're going to have to integrate twice to turn f double prime into f. Everybody agree? Okay. So, if I want to get f prime, don't I need to integrate f double prime? Does everybody agree with that? Yes or no? To get f prime, I'm going to integrate f double prime. Everybody agree with that? Okay, so in other words, I have to integrate this. And by the way, for integral purposes, is everybody okay with writing it like this? Okay. All right, so how about Jeffrey? Can you perform the power rule on this to integrate? What do I get? Okay, just do it one step at a time. I'll leave the 3 alone. What do I get when I integrate that? X to the what? Over -1 plus c, right? And then, yeah, you're right. You end up with -3 over x. Everybody agree that that's f prime? Okay. All right, now before I integrate that, I can find c. Can I? Can I use this along with this to find c, guys? Do you agree with that? I can use that initial condition to solve for c here? Yes?
Is there ever a time when you need to take a double, where you have to integrate twice without knowing any condition to solve for c?
Sure. That's a good question. Let me see if it comes up in... Yeah, it might come up... yeah, it comes up in the next example. Okay. Okay, good question. You're always thinking ahead. Very good. Okay, that's good. Okay, so you guys, everybody okay with where I'm about to go from here, that I can use that along with this to solve for c at this step? Okay, so Jack, what do I do then? I replace this with what?
You replace that with 5.
Good. And at the same time, I can replace that with what? 1. Good. And so clearly I get c equals what then? Let's see. 8. Everybody agree? I get c equals 8 if I solve for c there? Okay, once you find c, I want you to update this, or refresh it, whatever you want to say. Okay. Any questions so far? All right, now I need to, what do I need to do to this to turn this into f? Christina, what do I need to do to this to turn this into f? I need to what? Okay, divided by 0. So the power rule you just discovered would fail, right? Good, okay. Okay, and so then the antiderivative 1 over x is? Value of x. Yep. Plus what? Plus C. Okay. And that would become F, right? So you see how she integrated that, guys? Okay, so she integrated, and now I can use this, can I? I can use the fact that f of 1 is 2 to find this C now. Everybody agree I can use that to find C? Okay, so is it okay if I come over here, guys? I'm running a little bit low on space here, so here we go. Okay, so I'm going to replace this with what, Haley? What do I replace f of x with, knowing that f of 1 is 2? 2. And at the same time, I'm going to replace x with what? 1. Good. Okay, and everybody agree I should now be able to solve for C here? What's the absolute value of 1? Well, no, wait. What's the absolute value of 1? One thing at a time. What's the absolute value of 1? 1. What's the ln of 1? 0. Okay, so that's 0, right? So everybody agree, end up with this. And so clearly C is what? Negative 6. And so once you find C, I want you to update this equation. So updating it. Whoops, C equals 6, negative 6. Sorry about that. So you get C equals negative 6. Everybody agree that that's my original function then? Based on all the given information, I was able to figure out my entire original function, right? Okay. All right. Okay, so everybody try that example 14. It should only take you a second. Okay, well, just go ahead and write down what you think it is. Think about your derivative rules backwards. You got to constantly think about your derivative rules backwards here. Try and do it without peeking, guys. Just think about your derivative rules in your mind and then think backwards and start writing what comes out. Right? Okay. All right, here we go. Okay, obviously we're starting with f double prime. We need to get back to f. So clearly we need to integrate twice, right? Everybody agree the first time you integrate f double prime, it'll turn to f prime. Okay, so what is the antiderivative of sine? I don't know. Kevin. Okay, yep. Since the derivative cosine is negative sine, what's the antiderivative of sine? Good, good. Negative cosine. And then plus c. Everybody agree? Okay. Now, I don't have any initial conditions, so everybody agree? I'm not going to be able to find c this time. I have to just leave it as c. Okay, now when you integrate that, isn't that going to turn into f? Isn't it? Okay, so think about it. Just leave that negative alone and let's just worry about that. What is the antiderivative of cosine? Well, you all know that the derivative of sine is cosine. So going backwards, what's the antiderivative of cosine? Just sine. Plus, now be careful, c times x. Like if that was a 5, wouldn't the antiderivative be 5x? Wouldn't it, for example? So everybody agree it would be cx? But then I got to put a what? Plus c again. Yes? No, okay, let me start over. Let's go back to the beginning. You're trying to integrate sine. You know that the derivative of cosine is negative sine. So going backwards, when you integrate sine, you need a negative. Got it? Okay, what I did then is I just left the negative alone. I brought it down, and I just said, okay, what's the antiderivative of cosine? Well, think about it. You know that the derivative of sine is just cosine. So going backwards, the antiderivative of cosine is just sine. Got it? And that's it. Keep it simple. Right? All right, now you're right. How do you differentiate this? Well, there's a couple ways you can do it. You can call it C1 and C2 if you want. Or if you want, I don't care, you could call it CX plus D. I don't care. However you want to differentiate it. The bottom line is those are all constants. Yes, they can be any real number constant, positive or negative. Everybody agree? So either way is fine with me. Is that clear? So I don't care. You can write it either way. Just make sure you differentiate between the two. Is that clear? Yes?
It makes sense to put a tick mark next to one just to remind you that that's from taking the original.
No. Not necessary. Nope. Okay. Now, I'm going to have you do an AP question in your group. And again, because of the decimals and all that, I'll let you use a calculator. But before you start, hold on a minute. This, you guys, I'm telling you, I can't put enough stars around this thing. And arrows. Everything points to this. Because, you guys, now that all this drill is done, I've been drilling you all hour on this. Now that that's done and hopefully in place, most of the rest of what I'm going to do is application with this stuff. Is that clear? Okay, so you understand why I needed one good day of heavy drill before we can move on? Quick. Okay, and so this is the way I need you to start thinking. Okay? All right, this is the way I need you to start thinking so you can apply these, because I'll tell you right now, there's very few plain old integrals on the AP test. Most of the integration on the AP test is application. Okay, so you see where I'm at now? Okay. All right, so listen closely. Before beginning to solve any AP question where you know you're either going to differentiate or integrate, I mean, right? I mean, every application they're going to give you on the AP test is either going to require integration or differentiation, one or the other, right? So it is not always going to be obvious which one you need to do. So what do you need to look at? You need to look at the what? Units. Very good. You need to look at the units. The units tell you what to do, whether it's differentiate or integrate. So let's look at a situation. Okay. If they start you out on the AP test and they say, okay, let's talk about some function C of t. And again, they might give you a table of C of t values. That might give you a function for C of t. They might give you a graph of C of t. I don't care what they give you. Look at the units. Okay? Okay, what are the units on C? Cars. So they're going to say, let C represent the cars, number of cars C that pass through an intersection after t minutes. Okay, so obviously C has units of cars and t has units of what? What? Minutes. What would be the units then on the derivative or rate? Remember, the derivative function is the same as the rate function. That's what a derivative is. So what would be the units on C prime? Cars per what? Minute, wouldn't it? I mean, think about that. Think about that. If this is C of t, and you got cars up here, and you got t here in minutes, then whatever the curve is, when you take the slope, isn't the slope or derivative just change in y over change in x? So what would the units be on that? Cars per what? Minutes. When you find the slope at one point, or if you find one derivative value, everybody agree the units would be cars per minute? Everybody agree with that? Yes? Okay. All right, so what if you were going to work backwards then? What if they gave you some function, and I don't know, it doesn't matter what it is, I don't care what they call it. What if they give you some function, they call it P, and they say the units are cars per minute, and they ask you to find the number of cars? What are you going to have to do to that function to turn it from cars per minute back to cars? You're going to have to integrate, aren't you? Do you understand how this is just the opposite of taking the derivative? So if they call P some function with units of cars per minute and they ask you to find number of cars, aren't you going to have to integrate to go from cars per minute back to cars? Aren't you? Okay. So what if they gave you, I don't know, bugs per day? What if they gave you a function and they said the units are bugs per day? What would happen if you integrated that function? You'd end up with what? Number of bugs, right? What if you differentiated a function that had units of bugs per day? You'd end up with what? Bugs per day, or bugs per day squared. I think you'd rather leave it as bugs per day to make it more meaningful. Does that make sense? Yes?
What does that mean?
What that means is maybe the rate at which bugs are, no, seriously, maybe the rate at which bugs are, leaving or entering a hive, right, is changing at a certain rate, right? And on a certain day, the rate is changing at a certain rate, right? Does that make sense? Okay? Yeah, it's kind of like acceleration, right? Does that make sense? If acceleration tells you the rate at which the velocity is changing, but the velocity is already a rate itself. So the acceleration is a rate of a rate, isn't it? Do you understand? That's it. If you understand what I just said, that's going to let you handle 100% of the application problems on the AP exam. If you look at the units, you'll know what to do, and then you just got to do it, whether it's by hand or on a calculator. This is it. I mean, like I said, that's why I put so many arrows here. This is the most important box from here on out. Got it? Did you put a bunch of highlights on this so you know to look at it often? Yes, especially when you're studying for the next test or whatever. Okay, all right. So, guys, I would let you try it, but we got like 10 minutes left. Okay, you can help me. We'll do it together. Okay. I know this is grueling, guys. Trust me, it is for me too, but this is just one day we got to make it through, okay? Okay. So, here we go. A company estimates that the marginal cost, again, look at the units. What are the units? Dollars per item of producing X items is given by this. So the units on that right there are what? Dollars per what? Item, right? And then this is the cost of producing what? One item, okay? All right. So it says write an equation for d of x that can be used to find the cost in dollars. Okay, so how are we going to go from that, which has units of dollars per item, to dollars? By doing what to that? I'm going to have to what? Everybody agree you're going to have to integrate that? Yes? Okay, so here we go. So to get d of x, you integrate. So you can help me here. Adam K, what's the antiderivative of 1.92 if the variable we're integrating with respect to is x? Okay, good. 1.92x. And then minus, Sandhya, what's the antiderivative of negative 0.002x? The antiderivative, what is it?
0.002 x to the negative 1 over negative.
Okay, right now, what's the power? 1. And so what's the power rule?
X is 0.
But wait, what's the power rule? What do you do to the exponent for integral?
Back to 500.
No, you say that again?
Oh,
You add 1. So what do you get? X, what? Squared over 2. Yeah, you add 1 to the exponent, divide by your new exponent. Okay. And then don't forget your plus c. Very important. Okay. All right, now hold on a minute. You guys, what is this right here? That's the what? That's the cost. That's an initial condition. So you can say that what? This equals what? The cost d equals what? 506.2 at the same time that x is what? 1. Everybody agree with that? So I'm going to put a 1 there and a 1 there. One item, right? When x is one item, the cost d is 562. You see how I did that? Make sense? So just because they don't name everything doesn't mean you can't do it. They try and trick you, but it's no big deal. You can handle it, right? All right, so simplifying this. What does this turn into, guys? 0.001? Is that right? Yes? Plus c. So this is what?
1.919.
Okay. And so then at this point, what? You get C equals what? What's 562 minus 1.91? Right. That tells me my lesson's too long, huh? By the way, I don't think that affects the recording, does it?
No, it's still recording.
Okay. But I mean, will it be blanked out on the recording is what I'm asking? I don't know.
Who knows?
Who knows? Yeah, I'll check later. Okay. So anyway. So guys, update your equation now. Okay, minus 0.001 x squared plus 560.081, right? Well, it's 0.02 over 2. I just simplified that to 0.001. Is that okay, guys? And now I want to find the cost of producing what? 100 items. So what do? Plug the 100 in where? In for what? dx or x? That's items. What's items? D or x? X. Everybody agree you'd plug that in for x now? All right, so you just punch this in your calculator and we'll call it a day, guys. All right? Is that what you guys got? I don't know. Fine, round to 0.08. So, okay, so that was an early introduction to an AP question where it looks very confusing, but if you look at the units, you should know exactly what to do and then just do it. Got it? I should have patented that before Nike did, right? Just do it. Yeah, I would be, yeah. Okay. Are we good, guys? All right, that was grueling. You can just relax the last 5 minutes, or you could get started. I don't care.
No.
All right, that's fine. Good news is what? You only got about what? Maybe 15, 16 problems or so? I don't know. I didn't count them, but some of them are really short. Oh, you do? You have all Easter break, or sorry, not Easter, Thanksgiving. Yeah. See what these long lessons do to me? Yeah. Yes. Thanksgiving.